Hello, Chem 2 students. Mr. Keister here with you again today. This is the video for Friday, December 11th, 2020, which is our scheduled 78th day of school for the fall semester. Big day today. This is actually our last day before finals week. Always keep in mind, though, the dates could change for a variety of reasons, but the lessons and the order that those lessons are presented will remain the same regardless. So let's take a look at our do-nows and see what's on our schedule for today. So today you're going to pick up page 101 on double replacement reactions. We got started on that yesterday. Talked quite a bit about solubility. That plays a big role in what we're going to do today. In fact, that assignment, which was page 100, double replacement reactions and solubility, was due today. Hang on to that. I did not collect it. But please check your answers. That stuff's very important. Like I said, it's very important to what we're doing today. So make sure you check your answers. If you're here in school, they're posted here on the board. If you or all of us are at home, then of course you can check the answer key on Canvas. All right, make sure you do that. So as I said, today is our last lesson for the first semester. Okay, we will learn how to identify, write, and balance a double replacement reaction, as well as how to identify and write a net ionic equation for two types of double replacement reactions, precipitation reactions and acid-base neutralization reactions, which we mentioned briefly yesterday. We'll go into a lot more detail on those today. You will have the homework assignment over this that is due on Monday. Also on Monday, your fall semester quarter 2 review is due. We've had that for several days now. Just like the quarter 1 review was, this one is also worth a lot of points. There'll be no answer key available, so make sure you put forth your best effort on it and check your work with your friends and or classmates. Again, with the number of points it's worth, it can most definitely be a real grade changer. Keep in mind, too, that the material that is on, probably more importantly, keep in mind that the material that is on not only this quarter 2 review, but also the quarter 1 review makes up a bulk of the topics that you are going to see on your final exam next week. Okay. Details on that have yet to be worked out. I've just taken a look at the schedule recently for that. It's changed quite a bit from recent years. And so it appears to me, at least initially, that you will be taking my final over 2 class periods, So we'll get about half of it done the first period and finish it up the second. That's the way it's looking now. Don't hold me to that yet. But that's the way it's looking right now. So we'll see. All right, we'll see. So let's move on to today's lesson, shall we? And there we go. All right, so today we're first going to start off with precipitation reactions, which is one of the types of double replacement reactions. All right, so double replacement reactions between two ionic compounds that occur in solution. All right, remember our reactant compounds are always aqueous. All right, and result in the formation of an insoluble product, meaning a solid, one that doesn't dissolve in water. It's called a precipitation reaction. All right, precipitation. So let's advance the screen here to the next page and look at this one. So here we have double replacement. Remember the general format for double replacement is compound in solution plus compound in solution yields another compound where we have to determine its solubility based on the rules we talked about yesterday, plus a second compound, again, also where we determine its state of matter or solubility based on solubility. Remember, in a double replacement reaction, the two positive ions in the original reactant compounds switch places with one another, hence the term double replacement. Okay, so here we have one. We have lead 2 nitrate and potassium iodide. I've already balanced it for you. That was kind of nice. Both of which are soluble. Well, let's look at that real quick. Why are they soluble? Well, remember nitrate compounds are always soluble. as are group 1A, of which potassium is a member of group 1A. Remember those rules, always soluble. Group 1A's, nitrate, acetate, and ammonium. All right, got to remember those. The other rules you need to remember too, but if you forget any of the rest of them, don't forget that one. All right, it will help. Okay, so over here, let's take a look here. Lead to iodide. All right, so iodide falls under the chloride rule. All right, the chloride rule says that all compounds that contain chloride or bromide or iodide are soluble except 3 exceptions. Silver, what else? Silver, mercury 1, and boom, lead 2. So lead 2 iodide is insoluble, meaning it is a solid. All right. Potassium nitrate, on the other hand, is most definitely soluble. Potassium's group 1A, they're always soluble. Nitrate is always soluble. So this is soluble. All right. So now we're going to get to work on this equation here. In solution, put a big star by this. In solution, just like in single replacement reactions, compounds are not intact molecules. If they're in solution, they are not intact molecules. Instead, they split apart, right? They ionize or dissociate into the ions that form them. When an equation is written in that way, it's called a complete ionic equation. We built this yesterday. We're going to look at it again now, all right? So let's look up here and split up our compounds that are in solution, all right? So lead 2 nitrate, all right, has a lead 2 ion, which is Pb plus 2, and it has 2 nitrate ions, 2 NO3 minus 1s. Notice it's not NO3 parentheses 2 minus 1. That's not what it is, all right? It's 2 nitrate ions. Don't forget that. Potassium iodide has a K plus 1 ion and an I minus 1 ion, but with that, one of each, but with that 2 coefficient there are 2 of both of them. Over here, we got KNO3, which is in solution. We're going to split that one. So again, with the coefficient 2, we have 2 K plus 1s and 2 NO3 minus 1s, 2 nitrates, all right? Now, what about this? Lead 2 iodide, PbI2, solid, all right? What's that mean? It means it doesn't dissolve in water, all right? It remains a solid, meaning the molecules remain bonded together, all right? Stuck together. So what you do with that, since this is insoluble, we leave it alone. Leave it alone, all right? We don't split it, all right? Doesn't dissolve in water. Water doesn't drive it apart, so it stays together. All right, so we're going to write a complete ionic equation now, all right? So we have Pb plus 2 AQ plus 2 NO3 minus 1 AQ plus 2K plus 1 AQ plus 2I minus 1 AQ yields PbI2 solid plus 2K plus 1 AQ plus 2 NO3 minus 1 AQ. These complete ionic equations are quite lengthy, all right? I'm not going to require that you write them on your homework or on the test, but I certainly want you to see how they are written, all right? You definitely need to know how they're written because I think in mastering, they ask you to do that on a problem or two. I'm not sure, but I'm pretty sure they do. But the important thing is how do we get from here to our net ionic equation? Remember, in a single replacement reaction that occurred, we had a spectator ion, all right? In a single replacement reaction, we had a spectator ion. In a double replacement reaction, we have 2 spectator ions, all right? Let's find them, all right? So again, spectator ions are ones that remain unchanged. They're not involved in the formation of the solid precipitate. Since they're not involved, we are going to remove them, all right? So let's see. 2NO3 minus 1 on both sides of the equation, out. 2K plus 1 AQ on both sides of the equation, out, all right? They're exactly the same on the left and on the right. The rest have changed. And so our net ionic equation then is Pb plus 2 AQ plus 2I minus 1 AQ yields PbI2 solid. That then is our net ionic equation. All right. So basically, what's the net ionic equation represent? All right. Basically, it's the soluble ions. The soluble ions that form the insoluble product. Which again, we call a precipitate. Hence the term precipitation reaction. All right, precipitation reaction. Kind of looks like a combo reaction. Well, it is basically two things combined into one. All right. The net ionic equation for a precipitation reaction is indeed a type of combination reaction. All right. So again, net ionic equations only include the ions and molecules directly involved in the reaction, not the spectators. All right, not the spectators. All right. So one more time. Remember, in a single replacement reaction, excuse me, that does occur based on the activity series. There is always one spectator ion to remove. In the double replacement reaction, where we have a net ionic equation, there are always two spectator ions that have to be removed. Okay? All right, so let's look at some more examples. Let me advance the screen here. Oh. All right. So, first things first. Let's look at this first one here. Let's balance the equation first. All right, that's always need to do that first. Looks like CO3, PA. Looks like we just need a 2 in front of KCl, and that'll do that. All right, so we'll balance the equation first. Always do that first. All right, then we have, let's see, KCl. Well, that's easy. That's definitely soluble. All right, group 1A is always soluble. Barium carbonate. Okay, most carbonates are insoluble. Most carbonates are insoluble, except if there's a group 1A in there or there's ammonium in there. And there isn't in either one of these. Barium's not either one of those. So barium carbonate is a solid. All right, so this is a precipitation reaction, the production of a solid, precipitate. All right, so let's split everything that's AQ. All right, so BaCl2, we got a Ba plus 2 ion and 2 Cl minus 1 ions. Remember, that is not Cl2 minus 1 or Cl2 minus 2. There is no such thing as either one of those. There are two chloride ions. Chloride has a charge of minus 1. All right? Don't get that confused. K2CO3, there are two K plus 1 ions and a CO3 minus 2 ion. Again, there is no such thing as K2 plus 1 or K2 plus 2. All right? K has a plus 1 charge. It's group 1A. But there's a subscript 2 there, so there's two of them. All right? Two of them. The solid we leave alone. Remember, it remains intact. And then KCl, we have 2K plus 1 ions here and 2 Cl minus 1. There's actually one of each within the formula, but with the coefficient 2, there are two of both of those. So, what are our spectators? Well, looks like chloride's a spectator and potassium's a spectator. All right. Again, I'm not going to make you write out the complete ionic equation. We're just going to kind of skip past that and go right to the net ionic equation after we cancel the spectator ion. So our net ionic equation then would be Ba plus 2AQ plus CO3 minus 2AQ yields BaCO3 solid. Again, your net ionic equation should always be balanced. If your original skeleton equation was balanced, then your net ionic equation should also be balanced already. Right? Shouldn't have to do anything else with that. All right, so let's look at the next one. Calcium sulfide, sodium chloride yields calcium chloride and sodium sulfide. All right, let's balance it first. Ca is good. S looks like we need a 2 in front of NaCl. All right. So let's look at our solubility over here. Calcium chloride. All right. So most chlorides are soluble, with the exception of silver, mercury 1, and lead 2, but calcium is not one of the exceptions. So this is AQ. And how about sodium sulfide? Most sulfides are insoluble. All right. But sodium's group 1A, which means it is soluble. So it's AQ also. All right. So everything's AQ. Wonder what that's going to result in. Well, let's look. Let's split up all the AQs. Well, in this case, we're going to split them all up. So we have a Ca plus 2 and an S minus 2. We have 2 Na plus 1s, 2 Cl minus 1s. We have a Ca plus 2 and 2 Cl minus 1s. And we have 2 Na plus 1s and an S minus 2. I think you already see what's going to happen here, right? You see what's going to happen? Ca plus 2, spectator. S minus 2, spectator. 2 Na plus 1, spectator. 2 Cl minus 1, spectator. Everything's a spectator ion. What does that mean? What's that mean? Well, when you put these two solutions together, what happens? Do you get the formation of a solid? Nope. So what's going to happen? If you said absolutely nothing, you're right. All right. We'll just scratch those out. And this is a no reaction. All right. So we can have a no reaction with a single replacement reaction. That's due to the activity series. We can also have a no reaction for a double replacement reaction. But what that means is there's no formation of an insoluble product. All right. So make yourself a note. If both products are soluble, right? If both products are soluble, no solid precipitate forms. All right. It's no reaction. All right. No reaction. Got it? Okay, so what you can do then, we'll balance the equation, we'll show the canceling of the spectator ions, and then you can just cross out the products and write NR. Be done with it. Okay? All right, let's go on to the next page. Just about done. The other type, the other type of double replacement reaction I want to talk about today that we mentioned briefly yesterday is an acid-base neutralization reaction. All right. So the two reactants are an acid and a base. All right, an acid and a base. Okay, so you should know what acids look like. All right, they're polar molecular compounds that, when dissolved in water, all right, form these compounds we call acids. All right. Remember what they look like? They all begin with hydrogen. All right. A base. All right. A base. Most bases are usually a soluble metal hydroxide compound. Now, there are other compounds that can form basic solutions, but this is the one we're going to focus on right here. A soluble metal hydroxide compound. Remember, most hydroxide compounds are insoluble. Right. Most of them. Group 1As aren't, of course, and some of the 2As aren't either. And so those compounds, when dissolved in water, produce solutions that are actually very basic. Okay. All right. And the products then of this double replacement reaction are a salt, which is a soluble ionic compound, and water. All right. So it's still the same format we talked about before. Compound plus compound, both in solution. Of course, acids are always in solution. And then the base has to be as well. Yields compound plus compound. But now, one of those product compounds is water. All right, is water. So let's balance this first. That's first. Actually, this one looks like it's already balanced. Okay, already balanced. So Let's do our solubility. NaCl, of course, is soluble, group 1A. Now, water. Water is not AQ. All right, what's water? You should know this already. We've talked about it lots of times. Water at standard conditions of temp and pressure is a liquid. All right, it is a pure liquid. All right, it is intact, just like a solid is. All right, it's intact, just like a solid. So I'm going to make a little note of that. We're going to leave this intact, just like we did a solid, because its molecules are stuck together. All right, those molecules are stuck together. All right, everything that's AQ, though, we need to split. We need to split. So we have, and this qualifies then as our salt. All right, remember, an acid-base neutralization is acid plus base. Acid plus base yields salt plus water. All right, but again, it falls under the guise of a double replacement reaction, because all four of those are compounds, right? And the reactant compounds are in solution. Double replacement. Okay. Remember, the salt, it's positive, and we talked about this before when we're dealing with acid nomenclature. The positive ion in a salt comes from the base. The negative ion in the salt comes from the acid. And again, that's because of the double replacement reaction that's used to produce it. Okay? All right, so back to what we were doing. Let's split this thing up. All right, so we have a hydrogen ion and a chloride. H plus 1, Cl minus 1. We have a sodium ion, Na plus 1, and a hydroxide, OH minus 1. Our salt is also, sodium chloride is also soluble, Na plus 1, Cl minus 1. Water, of course, is a pure liquid, and just like pure solids, it remains an intact molecule, so we don't split it. So, spectators. Well, looks like chloride's a spectator, and sodium is a spectator, all right? And so our net ionic equation is H plus 1 AQ plus Cl minus 1 AQ yields H, whoops, not Cl minus 1, dang it, OH minus 1, there we go, AQ, chloride was a spectator, shame on me. Yields water. H plus 1 plus OH minus 1 yields water, all right? Acid-base neutralization reaction, all right, produces a neutral solution, all right? Water's neutral, right? All right, so basically it's, what is it? Well, it's a common, like we said before, the net ionic equation is basically a combination in a precipitation reaction. It's the ions joined together to form an insoluble product, a precipitate. In an acid-base neutralization reaction, soluble hydrogen and hydroxide ions combine together to form water. Okay? So on your assignment for tomorrow, you are going to balance and write a few reactions of your own. You should know how these work now. All right. Make sure you balance the equation first. Make sure you determine the solubilities of your products based on the solubility rules. If anything's AQ, split it up. All right, split it up. Cancel out spectator ions and write your net ionic equation. If everything is soluble, then of course all the ions are spectator ions, and you will end up with a no reaction. The assignment also asks you to identify which type of double replacement reaction you're working with. So you need to make sure you read the directions carefully. You also need to write whether it's precipitation or if it's acid-base neutralization. All right. So again, that is our last lesson in the first semester. As you can see, we are not all the way through Unit 6.2, not by a long shot. Got a lot to go yet. We'll pick up with, I believe, our next topic in Unit 6.2 is redox reactions. We will pick up with that when we return to school in January. All right. So assignment is due Monday. Okay. Don't forget your big Q2 review packet. That's due on Monday too. That's a big one. Make sure you get that thing finished. All right. Make sure it's accurate. All right. Do your best work on that thing. It's worth a lot of points. So I think that's it for today. So until next time, this is Mr. Keister signing off. Take care, everyone. Stay safe. Stay focused. Keep working hard. Finals are here. Almost. Be ready for them. Stick with me now, folks. Let's get this first semester out of the way and get ready to move on to semester 2. So take care, everyone. See ya.